Hey, welcome back. Let's implement the static isValidChain method since we just wrote the test for that, and right now we're getting a type error that blockchain.isValidChain is not a function, which makes sense because it doesn't exist yet. So let's make the static isValidChain method. The argument to this is a chain array, and cool, let's save that. And that gets us past the first error. Nice. So the isValidChain method is expected to return a Boolean. It will either return a true or a false value. By default, let's make it return true. So as our one line in this method already, let's have it return true. And that gets us past a test case where we're expecting the chain to be valid when it has multiple blocks. So now when it comes to implementing this method, we're going to introduce the logic to enforce all the rules for a valid chain. If we find that any of the rules have been violated, we'll return false out of this isValidChain method before it gets a chance to get to this return true line. So the first case and the first rule that we have to enforce is that the genesis block is correct. So we should check the first item in the chain. We'll look at chain of 0, which is the first index of the chain array. If this is not equal to the block.genesis result, well, then we'll return false from the isValidChain method. Now, as we save this, well, we get a pretty weird result. Now we only have one failing test, which is weird because we've only written the code that should get 2 tests to pass out of the 4 we previously implemented. And the test that is now isolated is the one we're expecting true. So we have this return true line, which makes us believe that the chain should, or rather the isValidChain method should return true when there are multiple blocks. But it sounds like this line is always failing. Now, the reason why this line is always failing and returning false is that the chain of 0 is never going to be equal to block.genesis in JavaScript. 2 objects in JavaScript can't be triple equal unless they're the same underlying object instance. So unless we set a variable to block.genesis and then ask if that variable was equal to block.genesis, well, then it'd return true. But in this case, the chain of 0 and the block.genesis are 2 different instances, even though they're both the genesis block. Now, this is a stricter equality check than we need in this case. As long as the chain 0, in other words, the genesis block of the incoming chain, has the same properties as the genesis block, we want it to actually pass. So instead of checking strictly that chain of 0 is equal to block.genesis, we can get the stringified form of that object by using json.stringify, which is a static method in the global JSON class of JavaScript. So we can do the same thing on both sides, and we're going to compare the string form of both methods, which allows us to check the keys and values of each one of these objects. Now, as we save this, actually forgot to add a closing parentheses, but as this is saved, well, now we have 2 failing tests, which is right because we've implemented the code to get 2 out of our 4 implemented tests passing. We got the test where it checks the genesis block, and we had the test going where it returns true if the block is valid. So now we have 2 other rules to validate. First, the last hash references must be actually correct. And second, the block can't have an invalid hash. So to check both of those, we're going to have to go through the entire chain, which we can do with a for loop. So let's have for let I equal 1. And the reason why we're starting from 1 is that we want to skip the genesis block, which has already been validated at position 0. We want to go up to the chain's length, and we're going to increment I every time. This allows us to look at the current block in the chain. So let's make a constant within each loop that is set to chain index I. And the first test that we need to get passing is that the last hash references the previous block's hash correctly. So let's make a constant called actual last hash. And then we can access chain of I minus 1 and then get the hash field of the chain's block that is prior to this current block. All right, cool. So now it'll be useful to have constants for all the fields in the current block so that way we can validate them. So let's grab the timestamp, the last hash, the hash, and the data from the block using JavaScript destructuring syntax. So now we're going to have a local timestamp last hash, hash, and data constant for each one of those fields matching those that exist in the current block object. All right, so now we can check whether this last hash matches the actual last hash here. We'll check if this last hash string, if it's not equal to the actual last hash, well, we're going to return false out of this function early. As we save this, nice. Now our test suite is isolated to one failing test, which means we got the test case to pass where the actual last hash reference must be correct. The final piece is making sure this hash is correct, and this is where we regenerate a hash using all the existing fields in the block to make sure that the hash that is presented is correct. So in order to regenerate the hash, well, we need access to the crypto hash function. So let's grab that right at the top. We're going to get the crypto hash method, which is going to be the result of requiring the local crypto dash hash file. And now we can generate a validated hash based off of calling the crypto hash function and inputting the valid fields, or rather the proper fields, which are the timestamp, the last hash, and the data. So if we make it to this point, we're going to make a validated hash constant, which is the result of calling crypto hash and inputting the timestamp, the last hash, and the data. I'll resize this so it's more visible. And now for the magic moment. If this hash that is presented in the block is not equal to what we expect, this validated hash, well, then we should return false from the isValidChain method. And as we do this, well, we get a fully green suite once more. Awesome. So the isValidChain method is implemented in enforcing all the rules for the chain. Cool. So one optimization we can make is we can inline this destructuring. So instead of creating a block constant, well, we can make our code instantly access all those values from chain of I. It'll destructure right away. And there we go. That's a little more clean and still fully passing the test suite. Great. So this validates the Genesis block. This makes sure the actual last hash is correct. And it also validates the hash itself based on all the fields that are present within the block. Very cool. Now that the code for validating chains is working, let's move on to writing the code for replacing chains next.